皆様お待たせいたしました。ただいまより Measuring for VDI Success XenServer XenDesktop Turning for Optimal GPU Performance in LAN Environments と題しましてセッションを行ってまいります。こちらのセッションは同時通訳講演となっております。ご聴講の際は皆様のテーブルの上に置いてあります同時通訳レシーバーをご利用ください。日本語通訳はチャンネル1番となります。ご利用の際はチャンネルの音量とそして番号、日本語が1番となっておりますのでお確かめください。それでは エヌビディア、ジェレミー・メインさんよりご講演いただきます。お願いいたします。
Okay, this time I'm starting out in English. So, hello everyone. I'm Jeremy Main from NVIDIA. I'm a senior solution architect for NVIDIA Grid. So this session is focusing, the previous session was VMware ESX. And this one is focusing on Citrix XenServer and how to tune XenServer to get the best possible performance. So to understand about our GPU requirements, we need to talk about what that really means. Then talk about how to monitor GPU performance and a few examples of what typical operations look like from a GPU or CPU perspective. And then I'll go into the XenServer tuning so you can tune your performance to get more bang for that server dollar, or server yen, excuse me. So understanding GPU requirements means you need to understand your existing limitations. If you have a workstation that your users are using, you need to understand the memory, the CPU speed, the number of cores, the amount of memory, and probably most importantly, if it's a 3D application, what GPU you're using. Because applications can be limited by their performance for many different reasons. It could be basically being held back by the CPU not having enough cycles to process. Or, in the rare case, it could be the GPU is not able to process the number of rendering calls at the frame size and the frame speed that the user requires. So without understanding these requirements, it's easy to try to deploy a VDI solution that makes users angry and want to kill their IT personnel. So it's really important to analyze your existing infrastructure to determine what sort of minimum requirements you need to apply to a VDI environment. So if you're thinking about monitoring your environment to understand what you need to be successful, there's 3 layers of monitoring that I would suggest that anyone considering VDI should use. First, within the organization, or if it's your organization or a customer's organization, you need to determine a target group that you would like to study for a virtualization deployment, or excuse me, a VDI deployment. Now, in this group, you could use a tool that is made by Lakeside Software. It's a free tool. It's called SysTrack that would allow you to install that on each workstation. And that will collect statistical data about all the applications, the amount of CPU, memory, GPU, network, and log that to an on-premise SQL server so you can understand that group of users' application usage, their CPU requirements, memory requirements, and also GPU requirements. So after you have an overall view of what a typical user does in a day, when the peaks of using Internet Explorer are, it's probably before lunch and after lunch, or when they open up Outlook and start sending emails as opposed to starting up SolidWorks and actually working on a design. You can now look into a single system monitoring and probably the most efficient way of monitoring a single system is to use the Microsoft perfmon tool. And with this, you would be looking at, of course, CPU and memory and your disk IOPS, as well as the NVIDIA performance counters, NVWMI, which can track GPU utilization and GPU memory utilization. So for your core applications, your 3D design applications, you can basically use perfmon again with the NVWMI components to see real deeply into what operations consume how much CPU, memory, and GPU resources. So if you rely primarily on evaluating using benchmarks as opposed to actual real-world usage, you might be preparing too many resources for users, and you're going to underutilize your hardware. So I'm going to talk about that. So with benchmarks, they're primarily designed to test the CPU and, depending on the benchmark, the GPU, and stress that in a way and with a frequency that a typical user will not perform. Now, trying to determine the actual maximum GPU performance that a GPU or an application can deliver, benchmarks are good at testing that. They're not good for simulating multi-user environments or vGPU utilization. So using perfmon and NVIDIA WMI performance counters, it's very simple to be able to actually use an application and look to see how the CPU and GPU utilization is not constantly high. It comes in peaks and valleys. So here I've just separated out some of the different. This one is actually using a CAD application, and I'm using this, looks like the outer shell of an SUV. And I'm simply rotating the model while I'm capturing the CPU and GPU utilization. Then I try to do panning, then zooming, and then actually in sketching. And as you can see, a lot of times it's the CPU that's being utilized the most in all these applications. So in a virtualized environment, adding CPUs may contribute to improving performance. But the point I'm trying to make here is that even in these applications, the GPU utilization is probably averaging about 30% in most of these operations. So that means this GPU can be utilized for other virtual machines. So next, I'm going to talk about how to tune XenServer. Probably the first step for tuning XenServer, if you have two NVIDIA grid cards in your server, is to create custom GPU groups. Now, the reason why you need to do this is because in most modern NUMA compliant systems, the GPU groups, or the GPUs, are not represented as single entities to the hypervisor, but as a homogeneous group. So to create the group, we're creating it with the purpose of understanding which CPU socket that GPU is associated with. So here I've highlighted in red and in green the two GPUs that are associated with socket 0 and socket 1. So I probably shouldn't go too far into the details of creating the GPU groups, but it's very simple to do, but you have to do it from the XenServer hypervisor shell. You can use that, you can SSH into it, or through the Zen Center console, you can access the shell and create a GPU group using the XE-GPU group create command with a name label that allows you to understand which GPU the socket is, which GPU socket the GPU is associated with. So in this example, I've said grid K2 on socket 0. Next, when we create this GPU group, we now need to associate the physical GPUs to that group. So here we're using the lspci command in the hypervisor, and we're filtering using grep for NVIDIA. And this will give us a list of the GPUs that are currently attached to the system and the hypervisor can see. So basically, PCI IDs that begin with 0 excuse me, will be associated with socket, or starting with 0 are associated with socket 0, whereas PCI IDs that start with 8, or I think it's 5 or 3, start with, are associated with socket 1. So now that we have these PCI bus ID numbers for the individual GPUs, we need to add them to our GPU group. So doing the XE physical GPU list PCI ID, we're going to get the UUID for the actual physical GPU resource. And this is required to add to the GPU group command. So to add that GPU to the GPU group, you use the XE pGPU parameter set with the UUID for the physical GPU that we just queried, and then the GPU's GPU group UUID. Then you need to repeat that for all the other GPUs that are in that same socket, and repeat for the GPU's group for socket 1, and add those GPUs to that as well. So once this is completed in XenCenter, for a virtual machine, you'll now see, if you assign a GPU to it, you will see a selection that says grid K2 on socket 0, grid K2 on socket 1. So this is important for probably the next step, which is understanding vGPU and process scheduling. So by default, XenServer does not constrain virtual machines to specific cores. When a process starts, depending on how many vCPUs a virtual machine has, it will decide where to schedule that process. So without restricting a virtual machine to a specific socket, we're going to end up with communication that's crossing the CPU sockets via the QPI interconnect to access the GPU. Just waiting for translation. Okay. So here are some examples of optimal versus non-optimal NUMA utilization. On the left side, the RAM, which is the memory controller, is integrated into the CPU, is communicating with a PCI bus which has an NVIDIA grid card on it. They're all communicating and accessing on the same socket. This will yield the best possible performance. Whereas on the right side, on the top right side, the virtual machine or the process has been scheduled on socket 1, whereas the communication to the GPU is on a PCI Express controller that is associated with socket 0. So each communication from the virtual machine to the GPU must cross the quick path interconnect, which causes a performance penalty. Now, the performance penalty might only be 5% or 10%, depending on how many QPI interconnects there are per socket. But it is a measurable amount of performance decrease if you do not properly consider the route from the CPU to the GPU. Now, on the lower right is an example of when you might have two CPU sockets populated, but one of the memory channels that the socket 1 controls is not populated. So if you have a process that's scheduled on socket 1, it has to store its memory on socket 0's memory. That access has to go through QPI for processing on the CPU, and then back through the QPI again to the GPU. So this would be an example of a worst case performance. So to eliminate this, the first step was creating a GPU group so we could isolate and understand where the GPU is relative to the CPU sockets. Next is to actually restrict the virtual machine's vCPUs to operate only on socket 0 or socket 1. So using this command here, the xe VM parameter set, and using the UUID for the virtual machine, and then the argument vCPUs parameter, and then this mask value is saying that this virtual machine can operate on the virtual CPUs 0 through 15. So it has the ability to execute on any of those vCPUs within the limits of the number of vCPUs that have been allocated for it in XenServer. So next, in XenServer, you can change the number of vCPUs that are enabled for a virtual machine. And in the end, I'll show a brief explanation of that. But if you need to increase the number of vCPUs, just changing it in XenServer is not enough. You actually need to change that setting via the command line. And this is due to the limitation of the number of sockets that Microsoft allows for its actual OS. So we need to represent additional vCPUs as additional CPUs on a socket to the virtual machine. So in this example, in XenServer, we've enabled 4 vCPUs for a particular virtual machine. But if you use the command xl vCPU list, you can see that there's 2 vCPUs that are actually been assigned to a physical CPU, but 2 other CPUs are not doing anything. That's because of this restriction on the number of cores or a number of sockets that the OS can support. So to allocate all the CPUs that we want, we need to modify the number of vCPUs per socket to the virtual machine using this command. It's xe VM parameter set platform cores per socket, and here we have 2 vCPUs, 2, and then vCPU max equals 4, and vCPUs at startup equal to 4, and finally the UUID for the virtual machine. So after applying this setting, you can start the virtual machine and do xe vCPU list. I believe, excuse me, this should be XL vCPU list, my mistake. And it will show that all 4 vCPUs will be operating. So what impact does all these settings have on performance? I've done a lot of testing and verification of XenServer with our GPUs and how to squeeze as much performance out of it. And I found that in our baseline performance, our baseline XenServer install, the performance increased using spec perf version 11, spec ViewPerf version 11. The increase was about 45% over the baseline performance that was untuned. So using VM pinning, custom GPU groups, and 4 virtual CPUs per virtual machine, you can easily improve your performance. So, and again, we have a grid website where you can get more information. We also have monthly newsletter and a YouTube channel. And of course, if you have any questions, please post them to our forums. You can follow us via LinkedIn and also on Twitter. So I'll open up the floor for any questions.
何かご質問のある方いらっしゃいますでしょうか。どうぞ挙手にてお願いいたします。同時通訳レシーバーがございますので、日本語でご質問していただいても大丈夫です。いかがでしょう。はい、では真ん中の方、ただいまマイクをお持ちいたします。
Is this able to apply multiple GPU for single user for CUDA compilation purpose?
vGPU or pass-through?
vGPU.
For vGPU, currently CUDA is not supported. Pass-through, CUDA is supported.
Pass-through, yeah.
So can you improve the CUDA performance using these tuning methods? Absolutely. Because what we're doing by this tuning is to make sure that we have the most efficient memory, computing, and GPU resources all in the same socket, so that communication is extremely fast. So if you have to cross the QPI, or your memory is not all populated, or the system is not actually using the GPU you thought it was, then you're adding delay in that computation. Now, depending on your CUDA application, if your CUDA application is actually you're registering data and then you're operating your CUDA kernels within the GPU and processing that data and adding more data all within the GPU memory, then the speed up would probably be less significant. But any communication from system memory to the GPU memory would definitely be sped up by applying these principles. And there's very little negative impact of applying these settings. It's a good question. Thank you.
はい、ありがとうございます。この他にご質問のある方いらっしゃいますでしょうか。今回が最後のセッションとなります。いかがでしょうか。
Last session. And of course, if you have any other questions that you want to ask, search my name or whatever, and you'll be able to find me. Or just jmain@nvidia.com, and it's easy to send me an email. 日本語でも大丈夫です。
はい、では以上をもちまして本セッションを終了とさせていただきます。